Welcome to Bashir Electric again. So today we are going to introduce ourselves to schematic programming. We are going to see how to use a Siemens schematic S7-1200 PLC. We are going to see the ladder part of it and also see how it is connected on power and how to use the input and the output pins. We are going to see the basics, though the programming, when it comes to ladder logic, the programming software they use for programming is TIA Portal, that we use to program and feed this ladder logic in the PLC in case you have the real hardware one, not the software. But this one, in our software, it gives us both provisions. We can do the ladder logic and the hardwiring together without having the real PLCs and the real software of TIA Portal. So there we go. We are going to have some simple logic here. Now before I start, allow me go through this PLC. So when we look at this PLC here, we have different pins. Let me have the internal view. So we have these pins here, 120 to 240 volts. So we have live and neutral. This one is earth, which means we feed here live, here neutral, here earth. Then after that, when you power it on, our PLC gives us 24 volts. This is live, this is neutral. And here we have input, digital inputs. We have digital input part A, that is when your address, this is I 0.0, I 0.1, I 0.2, like that up to I 0.7. So this one is digital input part B. When your address, you give I 1.0. This was I 0.0. This one is I 1.0, I 1.1 up to 0.5. And these ones we have analog input pins. So that's the basic on that side. And on this side we have the output. It is a relay type. We have here section 1, which means we have here this common. This common feeds this 0.1 up to 0.4. That means if you put here a common, it's going to be normally open with the 0 up to 4. Also we have the second set, that is a common enters here, that's 2, that feeds 5, 6, 7 and 0. That means if you address these pins, this will be Q 0.0, Q 0.1. This will be Q 1.5, Q 1.6, like that. So that is how we do how we understand those pinning. This is CPU AC DC relay. It means it's powered by AC. Input is DC, then output is a relay type. These are indicator lamps. So when we have this kind of diagram, you can analyze it in this format. So this is it. These are status lamps, the run, the stop lamps. And when we have it in the real image, that is how it looks. So let's power it and we see how it works. So I'm going to power it under that kind of image. So we are going to have here our power supply. We are going to have a live and neutral. Where is it? Live and neutral. Around here, let me zoom a bit. Then we have our cable. We come and connect here to live pin. Just connect there like that, it's enough. Then connect here, neutral, it's enough. So after connecting that one, now it gives us this 24 volts. When we have an input, in most cases we use normally open contacts, but you can use normally closed. It depends on the scenario and how you're going to come up with your ladder program. But in most cases we use a normally open contacts or push buttons. So when I have here my push button, can just call this one PB1, push button 1. So here we have what we call syncing and sourcing. When you have this PLC here, it gives us 24 volts. It means this 24 volts is going to be used by this input to signal the input pins, but this common also must receive. So we have a neutral or a negative which is going to act as a common. So if the common is negative, that means the PLC is sinking. But when you happen to give the input buttons, when you give them a negative, then the common you give it a live from 24 volts, then there the PLC will be sourcing. For much clarification on that, please, I have to make a video on order if in the comments. So for that one input, that's how we do it. So the 24 is going to be for signaling using the push buttons, then this negative we put it in the common. For all the digital inputs, they have one common. So that's how we do the input. Now the output we can have, you can use the same power supply from what we had above, no problem, but just here to be a little bit neat, let me have here an independent power supply. It's on. So we are going to connect, I'm going to connect this neutral. Since this is a relay, hope you know how relays work. Here this is a relay, I'm going to put here the common. Then I'm going to have my lamp. I'm just going to have here a simple lamp. Whereby now on this lamp I'm going to give live here, then I complete this side from the relay. Okay, this side is going to come as a neutral because we have fed in the neutral. Okay, so that means that here once the relay closes, of course it's going to complete this common with this pin, and this will be completed and our lamp will have to light. So now that is how we do connection. What is remaining is the ladder circuit. Let me take it back now. You see how it looks like in the rear view. So that is how it looks like in the rear view. That's how I made that connection. Now what we are going to do next is the ladder. Now in the ladder we use DC power supplies. I'm going to have here positive and I'm going to have here negative. Then we are going to have, when you come here in ladder logic, going to have my negative channel here, my positive channel, and I have my negative channel there. So we are going to have a normally open. I'm going to put here normally open, then I'm going to put here a coil. Now what helps these contacts here to communicate with the PLC is what we call the addressing. When we look at this PLC here, our push button, input here, our push button here we have given digital pin, that is input, it is I. So here we have to address I, capital. Then it is the first section, which is 0.0, that is our input. Then the output we addressed, it is Q 0.0. That was the output pin where we put our lamp. So now we complete this connection. Complete this one and complete. Okay, here we can use a neutral line for clarification. So if I zoom this ladder logic, that is how I've done the addressing. If you do a wrong addressing, that means the PLC will not understand what you're doing. Now when we play this one, when you have a simulation of this one, let's try and see. You see our PLC already, this lamp is lighting. I love it when it is in the real diagram like that one. So we simulate, you see this one is lighting. Oh, we have made an error, disconnection, the pin has moved here. Okay, so there we have corrected. Now when we do here a simulation, you see when I click, you know this is the push button I have to hold. So when I hold, you see here this one completes, here the coil lights, and also here now our circuit of the lamp does what is released. I mean it is completed and the lamp lights, as you can see. And since this is our push button, when I release here the mouth, it goes off. When I close, when I release. So that's how we connect, and that's how we use what our Siemens S7-1200 PLC. That's the basic. It applies to most of the PLCs. Now let's try to see how to power a motor direct online using this PLC of ours. So I'm going to have this setup is going to remain like that, only that I'm going to have this button. I'm just going to name it now stop, and we are going to have another push button. Allow me just space it to look neat. This one I'm going to name it start. Okay, then we are going to have, how are we going to connect this one? When I turn this one to 2D, we are going to have, let me zoom, we are going to have the same 24 volts. It is going to use the same. Now it's going to come at pin input 0.1. That's where it's going to come. So this one is 0.0, this one is 0.1. So from there, now when we come on output side, we are going to leave our lamp there like that. We shall see how to do in the ladder logic. Then we are going to have a coil which is going to act as our contactor. We are going to have a coil. Yeah, allow me just arrange the things like this. So now we are going to have this live. It is the same live which is going to come here to the contactor. Our contactor is K. Then now when we see the internal view, or we have here I01, it is the one that is going to give the one we had addressed to the lamp like that. Then now I mean is 0, D 0.0, then is D 0.1 around here. It's the one that's going to power our contactor. Are you seeing? They're also sharing the same live, but with the neutral, it is these respective pins that they are going to complete that normally open instance according to the ladder diagram. So that's how we do the connection. Now let's have a power circuit of our motor. For it, now we can have here a 3-phase around here. Then we have our circuit breaker, then we have our contactor. Then now for this time, let's just do that basic only, because we are just seeing how to connect this PLC. Then we can have our motor around there. So when we do the cabling, shall have here this one to the breaker, to the contactor, to the motor. I've jumped to the overload, just we want to see this basic here. Now what is remaining here, actually we rename our contactor. This is K, not KM, because there the coil we use the K, and this one can be MCB, no problem, MCCB. Say okay. So what remains basically, where the logic comes for the PLC, is the ladder programming. So we are going to have here our negative and positive. Just allow me have them around here. Okay, let me have them around here, live and neutral. So I'm gonna delete. So I'm going to have my channel. This is the live branch and this one is the negative branch. Complete here. So now I'm going to have anomaly closed as we always program daily. That is anomaly closed. Then I'm going to have anomaly open. Then I have again normally open, the one which is going to act as self-holding. So I'm now going to have a coil, that one. So this one is where we put it at pin I 0.0, and this one it was at pin I 0.1. So this one is now the coil, and our coil, this one, okay, we put it at it was Q 0.1, Q 0.1. That is okay. And now since this is a self-launching contact, it has to have the same address with the coil. That is Q 0.1. Okay. Then we do the cabling just as usual. Self-launching, this is how it behaves. Then we complete this. Now we also have the lamp. The lamp, we are going to have here a normally open of the coil, which is Q 0.1. okay, and it's going to power the pin for the lamp, and the pin for the lamp we connected it at Q 0.0. that is okay. Then we complete with the cable. Now with PLC, this ladder logic is not wired, but it is programmed and fed inside the PLC. It depends on which PLC we have. For Siemens, we have TIA Portal, we have LS PLC, that is the RS Logics. We have Mitsubishi PLCs, we have Omron PLCs, they use CX programmer. It depends on the PLC that you're using, so you have to get the basics on how to use those softwares. So now this is our contact, this is a breaker, this is the contactor, it is coil is here, and this is our indicator lamp to show it is on, which is at connected at pin Q 0.0, which is this one. This one, the coil is connected at Q 0.1, which is this one, and our stop is connected at pin I 0.0, which is around here, and the start push button is connected at pin I 0.1, which is here. So when we do a simulation here, remember this power supply here with this one, just I made them different here because of space. I didn't want to overpass cables, but if it is wiring in your panel, you use the same power supply, no problem. Now here when I close the main breaker for the power and I press here start, you see now our motor is running, and you see what happens in the ladder logic. When I press stop, it breaks. Whenever I press here a button or a signal, you see here in the ladder logic it also changes. So that one you will not see it. It happens inside the PLC, unless when you have that software TIA Portal and you are under monitor view, then you can be seeing what is happening whenever a signal is triggered. Start here, it starts. Stop, it stops. I think, like, I just loved using this very PLC. So this is how the PLC looks, the real PLC looks when you put it in your panel, and that is how it works. I cannot go any further. For the basic, we shall be seeing other tutorials on this PLC, but for the basic how to use it and how to come up with the ladder logic more so in this software of ours, Cade simulation. This is how we do or we go about with it, and this is also how you can just do the wiring in your real panel. This is how it is done, nothing much, as simple as you see it. Thank you for watching. Please don't forget to share and subscribe. See you in the next tutorials.